Okay, so we will now go on to this last addition of alkene, which is polymerization. For this part here, today's lesson, we'll just focus purely on addition polymerization. Because as I mentioned, I'll need you to get used to the various terms, such as example of what is a monomer, okay? What is a repeating unit? And lastly, what's the polymer's structural formula? Or sometimes they'll say the full structural formula. Okay, so we're focusing on addition polymerization and polymerization as a whole itself. So this actually touched quite a fair bit on macromolecules as well. So that's why you realize I got some reference to page 384 to 388. That's under macromolecules as well. Okay, so instead of waiting till then to cover this, I thought I'll just cover this whole part one shot. Okay, so let's start. So as mentioned, alkenes can do addition reaction. If they add to themselves, okay, they actually form these long molecules called polymers. So polymers are actually a very long molecule where the alkenes add to themselves. And this whole process is actually called addition polymerization. So this is the process. Okay. So what are the conditions required for this? The conditions, this one don't need to be too specific. It's just high temperature, high pressure, okay, plus presence of catalyst. So you need high temperature, high pressure, and also your catalyst to be present as well for the reaction to occur. Okay, now for this addition polymerization, I want you to take note. If you recall from the previous 3 examples, right, I always say draw your addition polymerization with your hydrogens to the top and to the left. But always make sure the bottom is empty. That's for addition reactions. Now, for polymerization, we're going to adjust a bit. When you are doing addition polymerization, so this is ethene here. So once again, ethene, let's practice a bit. Arya, come, what's the formula for ethene?
General formula?
Yeah, not general, just the formula for ethene.
Oh, C4H6.
C what? C4?
C2H8.
C4H8, you sure?
Yeah.
Okay, next, Akid.
C2H4.
Yes, C2H4. We do this so many times. Yeah. So must remember. Okay, so not C4H8, C2H4. So ETH represents 2 carbon. Okay. Okay, come. Don't worry. You have another chance to answer again. Okay, so drawing wise, I'll let you redeem yourself, Arya. How should I draw ethene?
Like the structure. CC.
Yeah, the structure. So CC first. Okay, then
like 4H.
4H.
Like
Like that.
Like not at the bottom. At the side.
Okay, so this one I have you draw. This one we will draw at the bottom. So for addition polymerization, we will draw at the bottom. You got one thing missing still. One thing.
One thing missing.
Yeah, one thing missing.
I think it's C2H4.
Yeah, C2H4, but got something missing in the drawing. What's missing?
Oh, sorry. CC double bond.
CC double bond, huh?
Yeah.
Okay, so this is an ethene molecule. You realize I shifted the hydrogens to the bottom. I left the sides blank. When you're doing polymerization, addition polymerization to be more specific, leave the sides empty. Okay, leave the sides empty. So what's going to happen here is that, as mentioned, addition polymerization is the alkene adding to itself. So I have many of this alkene. So we call it N. N means N number. Like, when you do math, N means like X number of things. Okay, so this ethene, I have N number of it. What's going to happen here in this particular reaction? Okay, sorry, I'm going to erase this, draw my arrow longer. Why? Because this will be high temperature, high pressure, okay, plus catalyst involved, catalyst. Okay, so in this reaction here, so I'm going to use blue to show you actually what's happening. I got my ethene, They will line up. Think of it as they are lining up in one straight line. They are lining up in one straight line. So they are just side by side. So this is another 18 molecule. I draw another 18 molecule. Okay, actually there's still many more on the left and on the right. Okay, Asan, help me. You just joined. Whenever you undergo addition reaction, what happens to the double bond?
Oh, the double bond breaks.
Double bond break, right? So I'm gonna break all these double bond. Boom, boom, boom. So each of these carbon now is short of one bond.
Yeah.
What's gonna happen next is okay. So Asan, you can. Oh, it's okay already. I won't call on you up for the next one. So what's gonna happen next is they will connect. So between the first 18 and the second 18 and the third 18, they will connect to one another. Okay? Thumbs up if okay. Okay? So you can see why I purposely left the sides empty. It's because when you line them up and then you break the double bond, it's easy for you to show that they're all linked up. If it's at the bottom, you're going to have problems showing them linking up. The reaction is going to be difficult to draw. Okay? So that's why we will always, when we do polymerization, we'll make sure that we'll adjust such that all the things are at the top and the bottom, we leave the sides empty. Okay? And after the whole thing, so obviously I'm not going to draw like many of it, right? So there's a summer, so you can actually condense the whole thing down. So this is where you show that the C double bond C is broken and it opens up. Then you put a bracket. Look at the way I draw the bracket. So the bracket has the bond sticking out because it's just to show you that thing is still linked to other things. And I put an N over here. So I want you to see the way how I draw. This is the structure of the polymer. So far, any questions? Thumbs up if okay. Okay. So as I mentioned, you're going to look at this thing called a monomer, the repeating unit, and the polyethylene structural formula of the polymer. So let's go based on what we have. So the full structural formula of the polyethylene is actually what we just drew. So I'm going to draw it again. So this is the full structural formula of the polyethylene. You must show every single bond that's inside. Then you put N. So this is a full structural formula of the polyethylene. It is the bracket with the N. N? Akit, help me now. What do you understand from the idea of repeating unit?
It repeats itself.
It repeats itself. So in this case here, what is, if you think in terms of the long chain, what do you think is the repeating unit?
The polyethylene.
The polyethylene is not the repeating unit. The polyethylene is like the whole molecule.
The N.
The N is just tell you that it repeats N number of times. So so think of it as it's not the N, it is not the whole thing. It's just a specific part, right? Just think of it as what do you think will be the repeating unit in this case here? Think of tessellation. You remember tessellation in primary school where you draw the same thing over and over again to stack them up? Okay? So what do you think is repeating unit? Yeah, can.
I'm confused. Is it like the CH thing?
Yes, correct. Very good. Okay, so good guess. So the repeating unit is actually this fellow over here. So what's the difference between the repeating unit and the polyethylene? What's the difference? Next one, Zachary.
It's just one unit.
So I want you to compare the two things that I drew. What's the difference between them?
There's a bracket and then there's n number of times.
So bracket and N is the one that actually makes the difference between your repeating unit and the full structural formula of your polyethylene. Ken? You need to know the difference. Huh? Okay, so good, Zachary. So repeating unit, full structural formula of the polymer or the polyethylene, there is a difference. The difference lies in the bracket and the N. So think of repeating unit as a stem. The full structural formula is just to tell you how many times the whole thing is in terms of the overall structure. Now, the last one is the monomer. So what exactly is the monomer? So mono stands for the single unit, and this is always before reaction. Okay, so Kiran, can you make a guess? What do you think is the monomer before reaction? What is the monomer? What's the single unit before reaction? Make a guess. Just make a guess.
The CH2,
CH2?
the C2H4 thing.
Correct. So it's actually your C2H4. So the monomer actually is the C2H4 with the double bond there. So it is the unit before your reaction. Actually, it is your alkene. Make sense? Okay. So this idea of addition polymerization, you must know the equation, which is over here. You must know how to identify the monomer, the repeating unit, and the full structural formula. Today, we will spend our time trying to do this whole thing here. Okay? Because it will take a bit of time for you to tinker everything, like to adjust and play around with it and get a sense of what it actually is. So this is for polyethylene. Okay, so let's go on to the next one. B, it says with a segment of polyphenol propene. This is a segment of polyphenol propene. Okay, so this whole thing here is a segment. So in actual fact, it is like sort of like a bracket with an end. But then because it's a segment, right? So they don't even draw the bracket at the end. Can? Thumbs up if you're okay in terms of me explaining part D first. Can? Yes, okay, good. Okay, so with this, can anyone tell me? Not anyone. Actually, now it's Arya turn already. Gladwin so sad. He left the meeting. I think he's scared. Okay, Arya, come next. Arya, what is the repeating unit?
CC. Wait.
Okay, in terms of this, how many repeating unit do you see here? Based on this structure, how many repeating unit?
3.
3. Where are the 3?
Like the H and then H3C. H.
So, like that, right?
Yeah, that's 1 unit.
So this itself that I've circled is the
1 unit.
1 unit. Repeating unit, correct. So I'm going to draw the repeating. Now, just to let you know, down here actually is a carbon. Down here is actually a carbon. Can? So how it actually looks if I draw the repeating unit, it will look like that. Okay, so it actually looks like that. CH3, H. Then I draw this weird ring. Don't need to worry about what the weird ring is. Okay. Can? So this is a repeating unit. So this is good. So you realize it's like doing tessellation. It's really trying to find out what's the pattern, the repeating pattern behind this whole molecule. Next, Asan, tell me, what do you think is the monomer? It is based on the repeating unit.
It's like the same thing, but with the C double bond.
Okay, so it's like the same thing. So let's draw the same thing first. Okay. Let's draw the same thing. Where would the C double bond be? Okay, what would the adjustments you want to make?
Remove the 2 like bonds that are not connected to anything.
Okay,
Then just draw the C double bond between the 2 C.
correct. So you realize it's trying to reconnect back to the original thing because you know that when you do polymerization, the double bond breaks, then it extends and joins to the side. So what you're trying to do is when you want to go from repeating unit to monomer, you're trying to recreate the steps where before breaking, so before joining to other things, you remove the 2 hands that's joining, and then you create back the double bond in the middle. So this is the monomer, this is the repeating unit. And if I want to draw the full structural formula of the repeating unit, it will look like this. So this is the full structural formula. And I'm sorry, let me rewrite this. So this is actually the full structural formula of your polyphenol propene. Okay. So so this is the polymer, this is the monomer, and this is the repeating unit. Can? Thumbs up if okay. Okay. Now, part E, I want to show you first. Okay? But before I show you something, let's ask Akid, your turn now. When I look at addition polymerization, what is the homologous series that undergo addition polymerization?
Hello.
Sorry?
What's the question again?
What is the homologous series that undergo addition polymerization?
Alkene.
Alkene, correct. So alkene, huh? Okay. Now, what is so special about alkene? What is its functional group?
C double bond C.
C double bond C. Okay, now, good. Zachary, help me. So in this structural formula of organic compound X, it undergoes addition polymerization. Can you tell me where specifically is the part that undergoes addition polymerization?
Where the C double bond C
C double bond C,
will
correct?
break.
So your focus is over here, this C double bond C. Okay? So although the molecule looks super big, looks like quite crazy, what I'm going to do is I'm going to condense it such that my focus is on the C double bond C. Okay, so what I'm going to do is I'm going to take in green. This part, I'm going to shift it down. This part, I'm going to condense it to CH2, CHO, and I'm going to shift it down. Okay, so I'm going to do this, condense it, and then shifting it such that my left and the sides are empty. Any questions with what I'm going to do? All okay? Thumbs up if okay. Okay, so I'm going to draw it out now. So this is how it will look. So C double bond C is the main focus. F on top, H on top. I do this. This is CH3. So I'm going to condense it here. I'm going to put a CH3 here. On the carbon on the right, I'm going to shift it down. This will be CH2, CHO. You all can see how I compacted it. And it now looks exactly like what I have here. My focus is on C double bond C. What I have over here, my focus is on C double bond C as well. I'm saving. Wait, you know what, this file is like a few hundred megabytes. I think 99, I think. Okay, so you can see here, anyway, the focus is on C double bond C, right? Okay, so based on that, you realize I don't need to care about the F, the H, and CH3 and the long group. My focus is on C double bond C now. So Kiran, help me. How to draw the help me first. Huh? What is this fella called? This whole thing called here. Kiran, practice unmute. Then after that, answer my question. So what is this called? I give you a clue. So I have M.
The monomer.
Monomer, correct. So this guy here is the monomer. It is the starting unit. Hey, Arya, help me. Next, your turn. Give me the repeating unit. What should I do?
Repeating unit.
Yeah, what's the repeating unit?
Wouldn't it be like the same as the monomer?
Okay,
And
so I draw the monomer first. So I draw the
Yeah.
monomer for you, okay? So that it's easier for you to try to tell me what to change.
No, but like without the.
Wait. Let me draw finish. Okay, then after that, I draw a monomer and then?
So yeah, you remove the double bond and then you connect the sides.
Like that.
Like the is a single bond.
Okay, middle cell.
Yeah,
So this is the repeating unit. Is it correct?
I think so.
It is correct. So you can see once you know the pattern of the reaction, you know that the double bond breaks and you open up to the side, actually realize the monomer to repeating unit is exactly like how the reaction would go. So once you open up, once you break the double bond, you open up the hands, or you open up the bonds. What do you think will be the structural formula of Y now? Asan, help me.
Yeah.
So Y is the polymer. So this is the polymer. So how to draw the structural formula of the polymer?
It's basically the same thing repeated, right?
So same thing repeated.
Repeating unit.
Okay, so let me draw one repeating unit first. What else would you want me to draw after this?
Just like the bracket.
Okay, so I'm going to draw the bracket. Then
Then you just the line extended.
line extended. So like that, that's all.
And then you write the
And can? So far, okay?
yeah.
So, okay, so you realize the few things to do here is always focus. So I just want to highlight what we went through. We always focus on the C double bond C. We always try to make sure that we condense and shift the things to the top and the bottom. This will give us the monomer. The repeating unit is about breaking the bond, breaking one of the bond in the double bond, and then opening it up to the sides. That's the repeating unit. So that's what RP, repeating unit. RU. After that, when you want to do a polymer, you'll just be putting a bracket and then put an N over here. So that's the polymer. Okay? So this whole part here that I went through in terms of how to do this addition polymerization, the questions can come in many variety. But as long as you're very familiar with the monomer, repeating unit, and structural formula of the polymer, you know how to shift the groups around the two carbons that has a double bond, you are more or less safe for this particular chapter already. So previously, it ends at this worksheet 7, then most of the students will just carry on with the rest. But quite a number of students actually requested for extra practices. Okay? So this worksheet 7 extra practice for today, this one here, you realize that it's about writing the various equations in terms of practicing your addition reaction for your addition reaction for alkenes. Okay, then it also got to do with the various kind of things that we went through, so you can do a bit more practice as well. Okay, so for this particular question 7, can you just do me a favor? Instead of monomer to polymer, can you just draw a thing here and write down here repeating unit? Okay, repeating unit. So for the rest of today, really like that. That's it. Short and sweet. I just want to end off with addition polymerization before I go on to the end of today with addition polymerization. I don't want to go through the rest because the rest will be something else really. I want you to consolidate on the addition reaction for alkenes and get really familiar with them. Okay, so these are all the practice questions here. So for the rest of the time, go and do the extra practice. Any questions, just feel free to text me and then I'll let you know whether you're correct or wrong. Okay?
Mr. Eugene.
Yes.
So like once this like worksheet is done, like the thick worksheet, I mean not thick worksheet, but like once this entire worksheet is done, then is that the entire organic chem?
No lah, you still got alcohol and you got alcohol, carboxylic acid, and polymer and a macromolecule.
Oh,
But macromolecule we did on addition polymerization already, which is a chunk of it already.
oh, okay.
Yeah. Ken? Any other questions? Okay, thumbs up if okay. Okay, so for today, that will be your homework. Tomorrow, we'll carry on with the rest of this worksheet, which is until page 28. Once page 28 is done, okay, chances I may press on with alcohols and carboxylic acid. But for that one, I may use the textbook to run through. Okay, for that one, I may use the textbook to run through. Okay, Ken? So that's all from me for today. Okay, that's all, everybody. Thank you very much. Bye-bye.
Bye-bye.
Bye bye.
Bye, Mr. Eugene.
Remember to do your homework.
Yes.